In today's lesson, we're going to solve exponential and logarithmic equations. So let's start off with the property of equality for exponential equations. So basically what this states is that if you have two exponential expressions that are equal to each other and have the same base, b, then we can simply drop the bases because the exponents would have to be equal to each other. So a very simple example would be if I had 3 to the x equals 3 to the fifth. Well, in order for these to be equal, given that the bases are the same, the exponents would have to be equal. So we could just drop the bases and say, well, x equals 5. So, and vice versa. If x equals 5, then we can give them the same base, or exponentiate them, and we can get 3 to the x equals 3 to the fifth. So it could go either way. Let's work out an example. So let's say I want to solve 3 to the x equals 1/9 to the power of x plus 3. Now, the bases here are not the same, but with a little bit of finagling, we can make these bases the same. So I can simply try this. I know that 1 to the 9th can be rewritten as 3 to the negative 2 power. Now I have the same base. But before I drop the bases, I really need to simplify this. So what I could do is use my power of a power and multiply it through. So I'd have 3 to the x equals 3 to the negative 2x plus negative 6, or minus 6. And don't forget we're distributing the exponent, or distributing the negative 2 here. So that's how we got that. Now I can drop the bases at this point, so I have x equals negative 2x plus negative 6, or minus 6. And now I just solve for x. So I'd add 2 to both sides, which would leave me with 3x equals negative 6. Divide both sides by 3, and I'd get x equals negative 2. And that would be my solution. Let's look at another one. In this example, we can't really write them as the same base. It's not convenient. So we can employ a different strategy. In this case, we could probably take a log on both sides. A log of, let's say, base 9, since we have base 9 here. So I would start off and say log base 9 of 9 to the x power. Let me make that look like a power. There we go. Is equal to, and of course what you do to one side you must do to the other. So log base 9 of 35. So now these cancel out, leaving me with just x. So when I evaluate that, we're left with that. And now x is equal to log base 9, or log of 9, log base 9 of 35 rather. And I just have to evaluate that and I'll get x. So if I don't have a calculator that can do that, I can use the change of base formula. So I would say log of 35 over log of 9. And I'd punch that in my calculator, and x would be approximately, we would say, 1.62. Okay. Of course, I could have done a natural log if I'd done change of base as well. Okay, so now let's look at the property of equality for logarithmic equations. So this simply states if b, x, and y are positive, given that b is not equal to 1, if I have a log base b of x is equal to log base b of y, well, y would be equal to x, or if and only if y would equal x. So if they're equal and I'm doing a log on either side of the same base, then what we're doing a log of is going to be the same. So quite simply, a very basic example of log base 2 of x and log base 2 of 7. Well, since they're both log base 2 and they're equal, therefore x has to be 7. X is equal to 7, vice versa. We can do it the other way as well. Here's another quick example. So here I have log base of 5 of 4x minus 7 and log base 5 of x plus 5. Since I have a log on both sides, a log base 5, I can just drop the logs. And then from there, solve it. Just solve for x. So x would be equal to 4. In this example, we were going to solve, and then we'll need to check for extraneous solutions. So when solving, be sure you're checking for those extraneous solutions. Now I have a couple log statements. I have log base 6 of 3x plus log base 6 of the quantity x minus 4 equals 2. The first step is I want to condense that to a single log statement, make that manageable, or more and more manageable with just one log statement. So I'll use the product property. So I'll write that as log base 6 of 3x times x minus 4 equals 2. The easiest way to get rid of the log, and that's what we want to do, is get rid of the log here, is to just convert this to exponential form. So the base here is 6, and remembering that the logarithm solves for the exponents, or it equals the exponents. The exponent in this case is going to be 2, equals 3x times x minus 4. And now I'm just going to solve this quadratic out. Now you could have multiplied the 3x up here or down here. It makes no difference. I'll have 36 equals 3x squared minus 12x. I'm going to want to set this equal to 0. That'll give me 3x squared minus 12x minus 36 equals 0. And let's see, I think that's going to be 3x and positive 6 times x minus 6, which equals 0. I'm going to set each one equal to 0, so I'll have 3x plus 6 is equal to 0, and I'll have x minus 6 is equal to 0. Solving both of these out, we'll have, let's see, 3x equals negative 6, x is going to equal negative 2, and this one, x is going to equal positive 6. Okay, so we need to check for extraneous solutions, so we're going to try both of these out, and we'll substitute these into the original equation. I'm going to start with the positive 6, so we'll have log base 6 of 3x plus log base 6 of 6 minus 4 equals 2. However, I'm substituting in 6, so let me fix that real quick. So that's going to be 3 times 6. There we go. That's going to give me log base 6 of 18 plus log base 6 of 2, and that should equal 2. I'll condense that to log base 6 of 36, which should equal 2. Well, it turns out
6 to the second power does equal 2, so 2 equals 2. That one checks out, so 6 is a solution. Now we'll go ahead and test out the negative 2. So once again, I'll have log base 6, and it'll be 3 times 2 this time, plus log base 6 of 2 minus 4 equals 2. Maybe you can see what's going to happen here. I do, but I'll point it out in just a second. Okay, I can stop here. That's because I have log base 6 of negative 2. You cannot take the log of a negative number. There is no number that will work. As far as, there's no exponent that will give you a negative number when your base is positive. So negative 2 is not going to work. So if you find yourself taking the log of a negative number, something's wrong. In this case, this is not a solution. It's an extraneous solution. So therefore, we only have one true solution, only one true champion of x equals 6 as being our sole solution. Like that.